Hello, my name is Monty Mitchell. I am a Six Sigma Black Belt specializing in supply planning profit optimization. The profit optimized S&OP, PO and S&OP for short, goal is to produce and execute the most profitable production schedule. It is a three-phase process. In Phase 1 we produce a least cost production schedule. Phase 2 is the have a plan, stick to the plan phase. PO S&OP has a specialized S&OP process that tracks supply and demand attainment which is required to execute the plan. And Phase 3 is the continuous improvement phase. This process will transform your supply planning into a high-performance organization. A favorite quote from James Harrington: "Measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. If you can't control it, you can't improve it." The goal. Supply planning provides a number of services to operations. First and foremost, operations and supply chain finance rely on supply planning to produce a feasible, profitable production schedule. We're going to use today Monty's Muffin Mix Manufacturing as our example. At Monty's Muffin Mix Manufacturing, 4M, we strive to be the best and most profitable muffin mix manufacturer. We are a small operation and must be as competitive as possible. To do this, our supply planning department, myself, must produce the most economical, least cost production schedule. Production scheduling has three conflicting goals: inventory reduction while improving customer service and operational efficiency, improve operations efficiency while reducing inventory investment and improving customer service, improve customer service while reducing inventory investment and improving operational efficiency. Here is another view of the three conflicting goals. A high-performance supply chain operation is achieved through optimization of these goals. It should be obvious that optimization usually works between contradictory constraints and different interests, such as sales interests and production interests. SAP APO can produce a production schedule that will reduce inventory and increase operational or operating efficiency by creating a time-supply balanced manufacturing cycle. In the end, the ultimate customer is the shareholder. Supply chain finance is the shareholder representative. Supply chain planning must produce a schedule that is least cost. The schedule must address operational efficiency requirements along with inventory investment and customer service. Supply planning must have and provide operations and supply chain finance reporting demonstrating attainment of these goals. 4M produces several muffin mixes made with white flour or whole wheat and packaged into regular and large size bags. Here we have an example of the schedule before the SAP APO, the Advanced Planning and Optimization System, sequences and groups production orders. We are a make-to-stock company. Our operations has a preferred manufacturing cycle. There is a preferred sequence of product production that is most operationally efficient. Each resource has its own characteristics that create setup time and waste. At Monty's Muffin Mix Manufacturing, major setups occur when the input material changes between white flour and whole wheat. Within the major setups, there are changeovers created when the packaging size changes from regular-sized packaging to large-sized packaging. These are minor setups. These scheduling characteristics are communicated to the planning system via the Setup Group field. Once the schedule is sequenced, operations wants large lot sizes. of the individual products to justify the time spent in setup. If products are sequenced correctly, then the minor changeovers are a bigger contributor to setup time and waste than at the product level. The same goes for the major setup. The production schedule must have minimum order quantities at each level, so there is a major lot size, minor lot size, and lot sizing for the product level. Each characteristic is called grouping. After a schedule is sequenced and grouped, the lot size of the individual products, minor groupings, and major groupings must be determined. We can't have massive runs. This will drive inventory investment up and the associated carrying costs. If the lot size is too small, setup time and waste increase, and available capacity may be reduced. Clearly, there must be an optimal balance between these conflicting goals. Least cost lot sizing, also known as economic order quantity, EOQ, is the correct method to use to determine a profitable lot sizing run strategy. The optimal order quantity is the point where setup costs equal the carrying costs of the inventory produced. Think of it as a balance. See the least cost lot sizing presentation for more on this concept. The goal is to produce sufficient lot size quantities at the major, minor, and product level that is economically justifies the setup cost, time, and waste of each group. We must also produce enough of each product to satisfy the demand during the period of time it takes to complete the manufacturing cycle. Thus, the time supply of each product in a family or group is equal when the production of a family is completed. In other words, the inventory for each product in that family will equally be running out just before the next production run of that same family. This method of production planning will significantly reduce inventory, setup time, and setup waste for resources where the major setup is at least 50% greater than the average minor and product setup costs. Both operations for operational efficiency and supply chain for inventory reduction are highly motivated to produce and maintain a time-supply balanced manufacturing production schedule or cycle. Phew, that's a mouthful. Here we see have a plan, stick to the plan, and those aspects that prevent us from doing that. Demand variability, the top left, and supply variability, both flowing through the bill of distribution. Creating a profit-optimized production schedule is the easy part. Executing the schedule is the tough part. In this chart, we see a graphic representation of the manufacturing cycle. In the schedule, each product has a sequence ID, one of the bars you see above. The white flour regular packaging sequence IDs are 1100, 1200, and so on. The white flour large packaging has sequence IDs in the 2000s, and so on. This chart shows 3 manufacturing cycles. A cycle is when it goes from 1100 up to the final product with sequence ID 4500 and then starts over again at the first product in the cycle 1100. Each manufacturing cycle is time supply balanced. Unfortunately, the best laid plans of mice and men often go awry. On the right side we see the projected schedule with large manufacturing cycles, keeping operations efficient and inventories down. On the left, we see the actual attainment of the production plan. Material shortages, staffing issues, demand variance, and many other factors will cause disruptions in the schedule and cause its inefficiencies. Also, these disruptions cause an imbalance in the time supply of the products. In other words, you could run out of the product before you get back to producing the product again. Thus, more jumping around in the schedule occurs. Getting out of sequence and out of balance can cause significant problems and inefficiencies. A Six Sigma approach to the S&OP process, matching demand and supply, will reduce variance and bring your production process under control. Please see the YouTube video PO S&OP The Goal Part B to learn how to bring these variances under control.